Hey, check it out. Woo! Woo! Yeah. Hey, Cliff, you want to hear the most annoying sound in the world?
I've already heard it.
Hello, everybody. So you've got an assortment of wires in front of your face, and maybe I have some explaining to do because you clicked on this video to see what the hell you were, because it piqued your curiosity. Maybe, I don't know. Anyway, so what I've figured out how to do, or what I hope this is going to work. I don't know. I'm going to build this thing first, and then then we'll find the location that we want to test it out for its first outing. But essentially, what I've done here is build. You may be familiar with a photoelectric sensor. These are pretty common in everybody's household. Well, at least if you have a garage, then then you should have one of these. A photoelectric sensor is used most commonly in the household. In residential spaces in regard to your garage opener. Okay, so if your door begins to travel down and then someone steps in front of it, hopefully they come in contact with the laser that comes out of this thing, and the door will open back up. Okay, so it's actually like in most cases it's a dry contact, normally closed function, so that it's constantly it constantly has contact unless it is reflected, or in some cases there's two of these. There's a sender and a receiver on the other side. This particular one was $12 on Amazon. It is fairly cost efficient. It runs off a 12-volt DC power, and it comes with a little reflector. So the idea is this reflector sits on the opposite side of your doorway, and the photoelectric sensor sends a signal, a laser across, and then it bounces off of that and comes right back to the same sensor, which receives it and says, you know what, this path is clear. The door can go ahead and come down. Well, what we're going to do in this particular case is actually we've set it up to an alarm and also an LED light. Well, where's it at? Here we are. So we've hooked it up with a 12-volt LED light. DC power is so cool, people. It can do some amazing things. 12-volt DC power to run all of this. I've taken the speaker doesn't come like this, and actually I've actually bought these what's referred to as a wire gland. This thing, I bought a big box of those. Of assorted sizes and whatnot, because I needed one for this smaller cable, and then after I looked at the speaker for a second, I was like, you know what, that would be really good to secure the little speaker, the little alarm speaker too. So I used the bigger gland to do that, the larger out of all those. And so we'll get into housing a little later on. Maybe this video is going to be a little bit longer than I thought it was going to be, but I also bought these little housings, right? And this is what I intend to do with these housings. Essentially, is the sensor comes with this little bracket. The bracket's going to mount here near the center, and then the wires will come down and go in. And then there would be an LED indicator light here. Maybe the wires will go in here, and then over here we'll mount our speaker, and then over here closer to the front side we'll have an LED indicator. Because in all actuality, the photocell itself has a red LED indicator light whenever that comes on whenever the beam is broken. This actually has if you see there, there's D and L. I've got it set to D, which is the normally closed setting. You could set this up for normally open, so that it does alarm the whole time that it is reflecting. But I have it set to normally closed, so it only alarms when it only alarms whenever there's something blocking the reflection. So these cases are, I'm not sure how much. I did buy a whole batch of them because this isn't the only one that I want to build. I got enough supplies here to at least build 2 of these right off the bat, and see how that's going to go. So essentially, we have an input. This is a 5.5 OD and 2.1 ID female connection for a power supply, and I have also got some of these 12 volt. Would it be better for me to just grab a fresh one? Well, I got it plugged in over here. So these little 12 volt power supplies, and it has a little cable that comes out. Whoa. Has a little cable that comes out, and it has the 5.5 OD and 2.1 ID. So 5.5 OD and 2.1 ID male connection, and that would go right in here, right? And we'll get to that in a second, because whenever I do plug this thing in, it does make an awful racket. It's very much a pain. So the positive runs along here. I have it go into a 3-point connection there, and the brown wire for that photoelectric sensor is the positive wire. It goes in there and powers that little light up. And then also in the positive terminal, I have an output going here and then splitting it also 3 ways again, one of which is sending power over to our speaker, and the other wire of which is going over here to this LED light. Then our negative cables, so both from the speaker come back to a 3-point terminal here and go into the black wire that runs to the photoelectric sensor, and then you have a single blue wire that comes out, and we tie it together with the negative terminal on that power supply outlet or inlet right there. Now, I did want to point out these little Wago clips. They are fairly expensive, but man, they're freaking awesome. They're really cool. I've used these in my professional life, and I'm using them here as well because they're really awesome. Also available on Amazon. They are kind of expensive, but again, you trade a little bit of money for things that are ease of use and things that can be used over and over again. If I wanted to take these components off and reuse them, I absolutely could. May do it if this doesn't work out the way we want it to. The whole point of me building this in the first place is I hope that maybe if this will work as an alarm for in the event that a spirit walks through a doorway or through an open space of some sort, you can set it up in a large room. Maybe, I don't know what the range is on this. Probably not a lot. It is a little tiny guy. There is a toggle here to increase the sensitivity. So that first toggle was to turn from normally open to normally closed, and the second toggle up here at the top is for increasing the sensitivity. But I don't know. You could probably have it turned all the way up, and it's not going to go a long way. This little guy will do as much as it can. I know it will span across at least a doorway, a door opening, a standard door opening. I don't see that it would have any issue outside of that. Oh, I almost lost a Wigo connector. Put that little bad boy back in here because we will use these in the future for other projects. So. All right, now that I've kind of ran you through the wiring for this thing, let's go ahead and plug it up, and you can hear the awful racket that it makes. I mean, it is an awful racket, but at the same time, it needs to be loud enough to indicate to anybody that there is a blockage. There is a interference in the laser, so to speak. So yeah, this may prove to be difficult to do. I'll tell you what, I'm just going to cut right here and then pick back up as soon as I get it plugged in. There you go. I promised you that you would get to hear that. That's coming from, and also the LED light is pretty bright. So there you are. See the reflector there, and then if I move it, and notice also there's an LED light on the top. There is a green indicator as well, but that's the red one comes on. It's nice and bright for one side of our housing, and then the blue light will be on the other side, the indicator on the other side. What's going on? Woo! Ah! Okay, let's unplug that power. Oop. Okay, so that's unplugged now. But yeah, that it proves that it functions the way that I want it to. But I got to go ahead and drill some holes and whatnot for the housing, and get my placement set up for all of this. And yeah, we'll come back together whenever it's all said and done. I think as far as this reflector goes, as far as this reflector goes and how it's going to be placed in the field, I'm toying with a couple of ideas. I bought enough of these little housings where I could really mount one of these like so on the other side of the opening, have it sit there, fill this thing full of sand or something, so that it's heavy enough where it's not going to get knocked over easily. Yeah, we'll see about that. We're just going to toy with some ideas. How about that? Okay, talk to you guys later on in this whole process. I'm pretty excited about this. I've been waiting on this for a couple of days now. So holla at you. Peace. All right, everybody. So here's the finished Model 1, so to speak. I did have to get some additional fasteners, and I went to Home Depot, and I got some 3 mil little screws. They're Allen heads, along with some 3 mil nuts to fasten this bracket down. But after I got to thinking about it, really, if I would have went about this a different way, I could have laid this thing flat down on the surface here and drilled 2 holes for those 2 screws to come in through the bottom, and fastened that sensor, that photoelectric sensor, directly to the surface of this housing that I got. Excuse me. So we have our wires going in, and then we have our little LED light here, and then right over here is our speaker. Now the speaker, the wire gland that I use to house that speaker in, actually it's quite bulky comparatively to the size of this whole thing. So I had to come off of the edge back here. I wanted it to actually be closer to this back edge, but because of the bulkiness of the nut that goes on it, I had to move it a little bit closer to the front. So I actually made 2 of these top pieces, and one of which I had to discard because it just wouldn't work the way that I wanted it to. After I'd already drilled the hole, that's when I noticed that it was too close to where the screws come in through the bottom, and there's a female location for those screws to land here. Right here is the input, the female adapter that we talked about earlier, and it did come with this little plastic thing to kind of seal that up so you don't get any kind of debris or anything like that. And over here, I again use that 3mm screw. I got this magnet from Home Depot as well, and just nutted it to the top of there. Now this kind of spins freely around that radius, and this serves as a pivot point, so this thing really can't come undone. Now, in the event that I have a metal surface on this side, I could easily I could use this magnet to mount that, and it'd be fairly easily. So here we go. It's time to plug it in. Let's plug it in. Again, we got a 12 volt DC adapter, and it's already firing off. Oh, let me just do this real quick. All right, so here we are back. I got it plugged in now, and you see the lasers coming through. It's reflecting off of this surface here, and it is quite annoying. But you have there's a green indicator light under here that tells you when the alignment has been made, but this thing is made in which case that if the alignment is off, you damn well know it. So yeah, it's loud, it's proud, and then there's the blue indicator light over there. So if the red one on this side, the blue one on that side, you should be able to tell if you're getting any kind of interaction or connection is disconnected with that photoelectric sensor, or disrupted, so to speak. Yeah, there it is. I hope you guys, we're going to test this first at Realistic Holistic. I bought enough components where I could build the second one of these, but the first location we want to test is at Realistic Holistic. They seem to have activity there on a really pretty regular basis. So I'm going to leave this with Rachel and get her to report back to me and to what kind of activity she may have there. We'll see. This is a physical object. You know, I don't know how it's going to react to something that's metaphysical. Maybe if something is manifesting or beginning to pull enough power to manifest, it may be able to reach some kind of physical point or material point in which it can block that laser. But yeah, we'll come back later with some input. Bye.